Cape Town is facing severe urban sustainability pressures from rapid urbanization, climate change, and water scarcity. Green infrastructure, hereon referred to as GI, including rain gardens, wetlands, and permeable pavements, offers nature-based solutions which have the potential to enhance water sustainability and water management and climate resilience. GI implementation in South Africa, and more specifically Cape Town, however, is scarce and under-researched. According to World Development 2024, the 2015 to 2018 drought exposed the shortcomings of traditional water infrastructure. Green infrastructure has been proposed, but its effectiveness within a Cape Town local context is not well studied. This has led to hesitation on the stakeholders' part into implementing these solutions into practice. Urban sustainability is defined by UN Habitat as meeting today's city needs without harming future generations. The principle and policy frameworks used to guide this research are that of the United Nations Sustainable Development Goals, specifically that of 6, clean water, and Development Goal 11 of sustainable cities, as well as the South African policy of NEMA 1988 and the Water Act of 1998. Urban sustainability is defined by UN Habitat as meeting today's city needs without harming future generations. The principle and policy frameworks used to guide this research are that of the United Nations Sustainable Development Goals, specifically that of 6, clean water, and Development Goal 11 of sustainable cities, as well as the South African policy of NEMA 1988 and the Water Act of 1998. The benefits of GI are that in terms of stormwater control, GI can reduce surface runoff, delaying peak flow and therefore reducing the risk of flooding. The aim of this research is to address how GI can be integrated to conserve water while sustaining long-term environmental, social, and economic well-being. The first objective is to analyze how GI can contribute to water management, conservation, and stormwater harvesting in Cape Town. The second objective is to assess green infrastructure's contributions to environmental, social, and economic well-being. And lastly, to evaluate green infrastructure case studies in Cape Town for integrated water management. Methodology. The research approach involves using a mixed methods design, combining qualitative and quantitative data, ensuring a holistic understanding of how green infrastructure functions in Cape Town's urban water systems. The quantitative methods involve a policy and document analysis of South Africa's NEMA, National Water Act, and Cape Town's integrated development plans, as well as a review of academic and grey literature to explore existing GI frameworks, stakeholder perspectives, and implementation barriers. For quantitative methods, there is use of secondary environmental and hydrological data to assess the performance of GIs in managing stormwater and improving water quality, along with GIS-based spatial analysis to map GI locations and compare pre- and post-intervention hydrological impacts. Data sources include Cape Town municipal reports, academic journals, and environmental studies, as well as governmental legislation and sustainability plans. Analysis techniques include a thematic content analysis for qualitative insights, and descriptive statistics and indicator-based evaluation.